3.1 is a section we're going to start talking about exponents. We've already discussed a little bit about exponents, so I'm going to remind you the parts of an exponent that we talked about before is 4 to the third, and remember the big number is your base and your small number is your exponent or power. And remember, when you have exponents, it actually means 4 times itself 3 times. So that's 4 times 4 times 4. Now, the very beginning, our first section right here where it says evaluate, this is just to remind you how we use exponents. Then we're going to get into some new exponent rules. And these rules we will use when we do the disjunction property. If we have variables out in front of the parentheses, we'll also use it when we multiply variables to variables, or if we have to divide variables. So these are going to be 3 new rules that we're going to learn, but our first section is just going to remind you on how to use them. So the first one, I have negative 2 to the third power. So remember, that's negative 2 times itself 3 times. And if you do have more than 2 numbers, remember you just want to look at them 2 at a time. So this is negative 2 times negative 2. Remember, if you have the same sign, your answer is going to be positive. So this is going to be a positive 4. And I'm going to bring that negative 2 over. So positive 4 times negative 2 gives you a negative 8. Remember, if you have the same sign, your answer is positive. If you have different signs, your answer is negative. Now for this next example, again, this is just review. I have 4 over 9 to the second power. This means this entire fraction is going to be raised to the second power, and that means I'm going to multiply 4 over 9 times itself. And we did something similar to this when we first started talking about exponents. And remember, you can cross cancel at an angle if there's something that will go into both 4 and 9 and there's not. So you're going to multiply the numerators times the numerators. So that's 4 times 4 is 16. 9 times 9 is 81. And remember, there isn't anything to reduce, or you could have done it at an angle in this first step. So this is in simplest form. This next example, 5 times 6 to the second power, we use this so when you do number 4, you know how to do this. So remember, with please excuse my dear Aunt Sally, you have to do your exponents before you multiply. So do not multiply the 5 times 6 and then raise 30 to the second power. That will be wrong. So I have 5 times 6 squared. So that's 6 times 6. And you want to work that 6 times 6 is 36. You don't have to write it like that if you don't want to. But 5 times 36. And if you want to, I'm going to come over to the side so you can see the scratch work. So I have 6 times 5 is 30. 5 times 3 is 15. Plus 3 is 18. So I have 180 as my product. Now the reason why we do number 3 is so when we do number 4, you know what to do first. So remember, when you evaluate, when you have x as a given number, I'm going to plug in this 4 inside the x. So I have 3 times 4 squared. So all I did was I plugged in a 4 wherever there's an x. Now this is exactly like number 3, except it's written with parentheses instead of the product sign. So please do not multiply the 3 times the 4 first. You want to do the 4 squared first, so that's 4 times 4. So I have 3 times 16, and 3 times 16, if you want to come off to the side and do the scratch work for it. I have 6 times 3 is 18, carry my 1. 3 times 1 is 3, plus 1 is 4. So I have 48. So these are just reminding you how we use exponents, what we do when we have an exponent, what it means to have an exponent. So now we're going to get into our first rule. And our first rule is the product rule. And when you have the product rule, you have to have multiplication happening. And our rule states that if you have the same base, you keep the base and add your exponents. So our example is a to the m times a to the n equals a to the m plus n. So that means I had the same base. The same base was the a, so I kept the base and I added the exponents. So why does this rule work? Well, I'm going to show you why this rule works, and then we're going to show you how to use it with the product rule. So why this rule works? Well, what is an exponent? What does that 2 mean? Well, that means I have x times x, right? So that means x squared is the same thing as x times x. Well, what is x cubed? That's x times x times x. How many x's do I have? 1, 2, 3, 4, 5. So that means I have x to the 5th. So our product rule says that if we have the same base, we keep the base and we add the exponent. So 2 plus 3 equals 5, so x to the 5th. So this is kind of proving that the rule is true. It makes sense. And this is why it works, because of the exponent, whatever it means to be an exponent, is that base times itself 2 times, that base times itself 3 times, and if you add up everything we had, we would get our answer for our product rule. So instead of doing it the long way, we are going to use our product rule. If we have the same base, we keep the base and add the exponents. If you need to have it out like this in an expanded form, just remind yourself on what the answer is, or to check your answer. That's a great way. So let's do our first example. So I have the same base. I have x as my base, so I'm going to keep that x. And I'm going to add my exponents. Now this first exponent is a 5. The second exponent is an understood 1. Don't forget, if there's nothing there, it's an understood 1. So I'm going to have 5 plus 1, which is 6. So x to the 6 is my answer for the product rule in simplest form. So I have the next one. I have the same base, which is y. And my exponents is, remember, an understood 1, a 3, and a 5. So 1 plus 3 plus 5, that's 4 plus 5 is 9. So y to the 9th is my exponent, the variable for the product rule in simplest form. Now notice that number 3 has numbers as well as variables. When you have numbers, you're going to multiply the numbers just like you would if you had a product, and we're going to use the product rule for our variables. So I have -2 times -2, that gives me a +4. And then for my x's, I have 3 plus 4 is 7. So I kept the base of x and I added my exponents. Let's do the same thing for number 4. So number 4, I have 12 times -1. I'm just going to look at the first two first. Well, this is just a 1, so 12 times -1 is just -12, and that's the only numbers we have. And for my x's, I have x's in all 3 groups. I'm going to have 5 plus 6 plus 4. 5 plus 6 plus 4. So 5 plus 6 is 11, and 11 plus 4 is 15. And you can do that in 2 steps if you need to. But take as many steps as you need to, but just remember you're adding all your exponents together. And we're going to pick up with the next rule on the next video.